Fine. So yesterday we have done some numericals. Today we are continuing with that. Okay, continue. The velocity of the particle, the velocity of a particle.
Sir, what is heading?
This is creating a lot of problems.
What is the heading?
Numerical.
Okay.
Problem, you keep on joining here. That's a interruption comes here. Okay, the velocity of a particle describing simple harmonic motion. Velocity of the particle describing simple harmonic motion is 16 centimeter per second. The velocity of a particle describing simple harmonic motion is 16 centimeter per second. At a distance of 8 centimeter from mean position. 8 centimeter from mean position. And 8 centimeter per second. Once again, the velocity of a particle describing simple harmonic motion is 16 centimeter per second at a distance of 8 centimeter from the mean position. And 8 centimeter per second at a distance of 12 centimeter from mean position. At a distance of 12 centimeter from mean position. Calculate the amplitude of the motion. Calculate amplitude of the motion. See, a particle making simple harmonic motion between A and B. For example, this is mean position. When it reach 8 centimeter distance, there its velocity is 16 centimeter per second. When it reach 12 centimeter place, then its velocity there decreasing 8 centimeter per second. What is the maximum displacement it can go? That's called amplitude. That's the question. Okay. Now, we know the formula. Velocity is equal to omega into velocity is equal to omega into, what is the formula we have written? V is equal to omega root of a squared minus y squared. Do you remember this formula? Check whether I have written or not this formula.
No, sir.
No. Take velocity of the simple harmonic motion. Just
No,
after
sir,
that in a note written. Check.
No, sir, we didn't.
V is equal to a omega cos omega t. And cos omega t we have substituted. And we have written this. Check. V is equal to a omega. Cos omega is, see, sin squared omega t plus cos squared omega t is equal to 1. And cos squared omega t is equal to 1 minus sin squared omega t. It's written just after velocity derivation. It's written. Is it written or not? Check.
Yes, sir. Yes, sir. We have written.
Written?
Yes, sir.
Just after expression for velocity, a omega cos omega t, that derivation in bracket, we have written this. I told you this is meant for numerical.
Yes,
yeah. You don't remember, but I remember. Okay. So V is equal to omega a squared minus y squared. A is acceleration, amplitude, y is displacement from mean position. Okay. So now first case, there are two cases given here. In first case, velocity is 16 centimeter. Omega angular velocity. Amplitude is fixed for both motion. then minus that time displacement is 8 squared. Any doubt? First equation.
No, sir.
Second equation, in second case, velocity is 8 is equal to omega into root of a squared minus y squared is 12 squared. Now just divide 1 by 2. You can find out a. Tell me the answer. So this formula you remember. This formula we have written just after expression for velocity of simple harmonic motion. This is solved. When you divide, this will omega will cancel. This will come 16 by 8. Take square on both sides. Answer of amplitude will come plus or minus 13.6. Plus or minus 13.06 centimeter. That means plus or minus means this side it will go maximum 13.6. Opposite side also. This is a mean position. Both side it can go. There's the answer. Okay. You try. If
Yes,
you're not
sir.
getting, you tell me. Got it?
Yes, sir.
Yes, sir.
No, sir.
You didn't get?
No, sir.
Divide 16 by 8, 2. So omega cancel. Then this will go root of a squared minus 8 squared divided by a squared minus 12 squared. Take square on both sides. 4 is equal to a squared minus 64. This is a squared minus 144. Cross multiply and do it. After solving it, this will be our answer, okay? Plus or minus 13.06. You try. If you're not getting, tell me. Otherwise, we cannot finish these numericals. Next question.
Sir, please can you go back to the last one? Yes, sir. Done. Thank you.
In a pendulum, next question. In a pendulum, the amplitude is in a pendulum, the amplitude is 0.05 meter. Amplitude is 0.05 meter. And the time period is, in a pendulum, the amplitude is 0.05 meter and a period of 2 seconds. Period of 2 seconds. Calculate the maximum velocity. Calculate maximum velocity. We know the formula A is equal to omega squared y. You remember?
Yes, sir.
Actually, it is minus omega
Yes,
squared
sir.
y. But here, minus sign shows they are opposite. That's all. We need maximum velocity. Okay. So here, write this formula. I have given 3 graphs. Do you remember? 3 graphs.
Yes, sir.
Please-
One of displacement.
Yes, sir.
What is the maximum velocity then? Can you tell me in that graph? Maximum velocity marked.
Minus omega A.
A omega, isn't it?
Yes.
A
Yes,
omega.
sir.
Velocity, maximum velocity is given A omega. Okay, we need omega here. How will you find out omega? 2 pi by t. Okay. So V maximum is equal to A is 0.05 amplitude. Omega is 2 pi by T, 2 into 3.14 by time, 2 seconds. 2 cancel. Then your answer will come 3.14 into 0.05. That is 0.1571 meter per second. This will be the answer. V maximum, you can see the graph. There we have written what is V maximum. Maximum value of omega it can attain. Three graphs have given displacement graph, then velocity graph, then acceleration graph. There you can check that. This is maximum values. Is it over?
Yes, sir.
Next question. A particle executing linear simple harmonic motion. Simple harmonic motion, you write just SHM, okay? Short form. A particle executing linear simple harmonic motion has a maximum velocity of 40 centimeter per second. 40 centimeter per second. And maximum acceleration 50 centimeter per second squared. Maximum acceleration 50 centimeter per second squared. Find the amplitude and period of oscillation. Find the amplitude and period of oscillation. So the formula, velocity maximum is equal to omega A. Amplitude maximum, acceleration maximum is equal to omega squared A for acceleration. This is a relation. Any doubt?
No, sir.
Now divide. Then you will get acceleration first. From here you will get omega. 40 divided by 50 is equal to 1 omega will cancel, A cancel, 1 by omega will come here. Okay, so omega is equal to 5 by 4 radians per second. This is omega. Then time period is 2 pi by omega. Substitute 2 into 3.14 into 5 by 4. Then final answer will come 5.03 seconds. This is time period. Is this over?
Yes, sir.
Next question. There are so many numericals. We'll go important ones now. A body executes simple harmonic motion. A body executes simple harmonic motion of time period 8 seconds. Time period 8 seconds. If its mass if its mass 0.1 kilogram,
Sir, can you repeat?
a body executes simple harmonic motion of time period 8 seconds. If its mass be 0.1 kilogram, comma, its velocity 1 second after, its velocity 1 second after, its velocity 1 second after it passes through its mean position. 1 second after it passes through mean position, be 4 meter per second. Find its kinetic energy. Find its kinetic energy, potential energy, and total energy. Find its kinetic energy, potential energy, and total energy. So data, time period 8 seconds, mass 0.1, V is equal to 4 meter per second. Okay. Now we need first a kinetic energy formula. Kinetic energy is equal to formula for kinetic energy is half K into
Half mv squared.
A squared minus Y squared, right? This kinetic energy formula. K can be written as M
Oh, okay, yes, sir.
A squared minus Y squared. This is kinetic energy. Potential energy formula half K Y squared. Total energy is half K A squared. A is the amplitude. Okay, this A should not confuse. Here amplitude. Now first we need here a kinetic energy to be calculated. But we need omega there, right? Omega and amplitude we need. A we need, omega we need. Two things first you have to find out. For this, we can use the formula V is equal to A omega cos omega t. V is 4. Amplitude we don't know, we can find out. Okay? But what is omega? Omega is 2 pi by t. So 2 pi divided by t is how much? 8. That means pi by 2. That is omega. Pi by 4, right? Pi by 4 is omega. So here you can substitute. A we don't know. Omega pi by 4. Okay? Into cos omega again pi by 4 time 1 second. Any doubt? V is equal to A omega cos omega t is the formula. Velocity given 4. Amplitude I'm leaving as A itself. Omega I calculated 2 pi by t. From this formula pi by 4 I got. Cos omega again pi by 4 time 1 second, because this velocity happening after 1 second it crossing the mean position. From there A we can calculate. Okay, 4 is equal to A into pi by 4 cos pi by 4. How much will come cos pi by 4? 180 by 4 how much? 45, right?
5.
Cos 45,
1 by root.
isn't it? So 4 is equal to A into pi by 4. What is cos 45? 1 by root 2, right?
Yes.
From here, A you can find out. Find the value of A from there. Copy up to here. Amplitude you can find out from here.
7.2, sir.
How much?
7.2.
A. A we can get 16 root 2 divided by pi. Keep it in pi.
Yes, sir. 16 root 2 by pi.
This is A. 16 root 2 pi, that is amplitude. Okay. Now total energy we can calculate. Kinetic energy. Kinetic energy is equal to, how much will come kinetic energy? Half m omega squared a squared minus y squared. Isn't it? So kinetic energy is equal to directly they're substituting. Yeah? Kinetic energy half mv squared directly they're substituting because why we don't know. So half mv squared they're substituting. So kinetic energy is equal to half into m 0.1. V we got from here. What is the value of V? We can substitute here and find out V value. Can you find out V?
Yes, sir.
4, right?
Sir, 4.
Yes, sir.
Four. So 4 squared. That is kinetic energy. Kinetic energy is 0.4 squared. Kinetic energy is 0.8 joule will come. Now potential energy is half K. Potential energy is Y is not there. Then total energy find out first. Total energy. Total energy is equal to half K A squared. Half K is m omega. Okay. M omega A squared is already calculated. This one. 16 root 2 by pi whole square. M is substitute, omega substitute and calculate. So we got now kinetic energy and total energy.
Yes, sir.
How much you got total energy? Total energy will come 1.6 joule. Then total energy is equal to EP plus EK. Potential energy we can calculate. EP is equal to ET minus EK. It is 1.6 minus 0.8. Then 0.8 joule. These are the answers. Practice more questions from this area, okay?
Yes, sir.
When you do numerical only, you will understand what exactly studied. Why 49 right now?
Sir, I'm already there, but joining with other device, sir.
Is it over?
Yes, sir.
Next, a particle is executing simple harmonic motion. A particle is executing simple harmonic motion of amplitude A. A particle is executing simple harmonic motion of amplitude A. At what displacement from mean position? A particle is executing simple harmonic motion of amplitude A, capital A. They're giving amplitude capital A. If in the question is given, take that A. At what displacement from mean position? At what displacement from mean position? is the energy half kinetic and half potential? Is the energy half kinetic and half potential? That means out of total energy, half kinetic, half potential.
Sir,
If
can you
that
repeat
way
at
statement is
uh, s- sir, amplitude A at what?
at what displacement from mean position? At what amplitude is A? At what displacement from mean position? At what displacement from mean position is the energy half kinetic and half potential? Is the energy half kinetic and half potential? That means out of total energy, half kinetic, half potential means potential energy must be equal to kinetic energy, right? Isn't it?
Yes, sir.
Sir,
Out of total energy, 50% kinetic, 50% potential means EP must be equal to EK. Then half into m omega squared a squared minus y squared. This is a kinetic. You don't confuse. EK is equal to EP. EK is equal to EP. Half K a squared minus y squared is equal to EP means half K y squared. Clear? Half m omega squared y squared. Half m omega squared y squared. M omega squared cancel. Half cancel. A squared is equal to 2y squared. Isn't it? Then y squared is equal to a squared by 2. Y is equal to a by root 2 plus or minus. Clear? That means if total amplitude is 4, it's not half the distance. Energy become half. Root 2 distance, energy become half. Clear? We may
yes,
think
sir.
total. Yeah. Normal people will think half the distance from mean position, energy will be half. No. Root 2 distance. Complete, please tell. One more day we need to complete the numericals. Then I will start gravitation, okay? Is this over?
Yes, sir.
A hospital uses an ultrasonic scanner. A hospital uses an ultrasonic scanner. Hospital uses an ultrasonic scanner to locate tumors in a tissue. What is the wavelength of sound? What is the wavelength of the sound in a tissue in which the speed of the sound is 1.7 kilometer per second? The operating frequency of the scanner is 4.2 megahertz. 4.2 megahertz. So here the formula V is equal to F lambda. There's a formula. You remember this formula?
Yes, sir.
Now we need wavelength, V by F. V is given 1.7 kilometer means 1000 into 1000. Frequency 4.2 mega 10 to the power 6. So divide. Then your answer is 4.047 into 10 to the power minus 4 meter. This will be your answer. Today, last question because it's only 1 minute. Let's finish it. Is it over? The audible frequency range of human ear. We can hear only audible frequency this way. The audible frequency range of human ear is 20 hertz to 20 kilohertz. Less than 20 hertz, dogs can hear. The audible frequency of range of human ear is 20 hertz to 20 kilohertz. Convert this into corresponding wavelength range. Convert this into corresponding wavelength range. Speed of the sound at ordinary temperature is 340 meter per second. 340 meter per second. So formula V is equal to F lambda. Lambda is equal to V by F. So first you calculate lambda 1 is V by F1. Second case, lambda 2 is equal to V by F2. V same in both cases, F1 and F2. We have to substitute. Kilohertz is 10 to the power 3 hertz. So your answers will come 17 meter to 0.017 meter. This will be the range.